Hello, I just wanted to take a few minutes to work through a couple of these examples so you have something to look at as you work through these questions. The main thing to remember here is that if we have a number to a rational exponent, let's say m over n, this is just another way of writing, or a different form of writing, the nth root, so the denominator goes in the index here, so the nth root of x to the m power. That's what you'll see as answers on this worksheet when you're changing from exponent form to radical form. Also, sometimes helpful, you'll realize, is that it can also be the nth root, so that doesn't change at all, the nth root of x, and the m can actually go inside, like x to the m power. So both ways are true and mean the same thing. Just sometimes one is more useful than the other. And then obviously, if they're equal, we can take something like this and change it to this form. And we'll see that a couple times too. So I'm just going to pick one here. Let's go with number 3. Write each expression in radical form. It's not asking you to simplify radical form at all. It's just asking you to write it in radical form. So by going by what we have here, we're going to say this is the cubed root. So this number goes here, the cubed root of n to the 5th power. Another variation would be the cubed root of 2 to the 5th power in here, which actually you may end up writing that as the cubed root of 2 to the 5th, which is 32. But this is what we're looking for right now for these questions. So moving down to the next set of questions, now we're going to go the other direction. This is like having the nth root of x to the m power. We're going to write this as x to the m over n. So this goes in the denominator, this goes in the numerator. So let's pick number 9 here. So number 9, we have 2. It's kind of like our x here, so this is going to be 2 to the 5 over 4 power. The index goes in the denominator. Now realize I'm going to throw in number 11 here too. This would be 2 to the, well, we see this is here, so that goes in the denominator. Well, what goes in the numerator? Well, if there's no exponent written out here, it's an understood 1. So this is 2 to the 1/3. So there's a couple examples from that section. This section mixes it up a little bit because it could have more than 2 terms in here. It also throws in the idea of a negative. So just as a reminder, if you have a negative exponent, so if you have a to the negative 3, that means it's 1 over a to the 3rd. So you're really doing, it means the reciprocal, so an a to the positive 3 that goes in the numerator, or in the denominator, and 1 is on top. So let's take a look at number 1. This is back to, it starts in our exponent form. So this time, instead of just having one number under here, we're going to have a radical, and we're going to have a radical, and we're going to have 5x in that radical. Now realize we have a negative. So in fact, I'm sorry to do this again, but I'm going to cross this out. Let's start again. I'm going to have, since we have a negative, we're going to right off the bat put 1 over 5x to the positive 5/4. So if there's a negative exponent, you automatically put it to the denominator. And now we can simplify this denominator. This is a 5x, which is going to be inside the radical. And remember, the 4 goes on the outside. it's our index, and the 5 goes here. And once again, we're not worried about simplifying our radicals. We are just writing them in radical form. We've already talked about how you're not supposed to leave a radical in the denominator, but we're not doing that at this time. Let's come down to 17 because this one's a little different. It has a decimal in there, but we know that we can change decimals to fractions. So we would write this as 6v to the 3 over 2, and now it looks familiar to us. We would have our radical. 6v will go inside the radical. 2 is the index, and 3 goes out here as our exponent. And even to simplify this more, when it is a square root here, we don't actually need to write it in there. So we could write that like that. The next one, write each expression in exponential form. This is just going backwards. Let's pick number 20 here to do. Number 20, we have 6x. That was in the radical, so that's going to be our base. Make sure you put parentheses around that because the whole thing is going to have the exponent of, and the 3 goes in the denominator, and the 4 goes in the numerator. And so that's our answer for that. So you should be able to work through those questions pretty well. The simplify ones at the bottom, we're more familiar with radical form, so you might want to think of this as, or change it to radical form first. So this is 9 inside the radical, a 2 here to the first power, because the 2 goes here, the 1 goes on the outside. Well, this is the square root of 9, which is 3. 26, we see the negative here again, so we automatically think 343 to the positive 4/3. And then, that's 1 over that, so we have 1 over, we'll have a radical, 343. 3 will go here, and the 4 will go out here. And then as you think through this or work through this, the cubed root of 343. So on your calculator, you can do the cubed root. On my calculator, I need to go to math. And you notice number 4 here has cubed root, so I'm going to click that cubed root of 343, and that's 7. So we have 1 over 7, but it's still to the 4th power, and so now we want to do 7 to the 4th power, and that is 2,401. And one last thing I want to show you here is we can do a lot of these without changing the radical form if you want to think through this. So in our minds, we're going to do number 28. Remember, this 2 on the bottom means we want the square root of 36. So the square root, the fact that we have a 2 in the denominator means square root. So square root of 36 is 6, and then we want to cube it. And then, so we have 6 cubed, which is 216. Now, if that is not something you're capable of doing right now, then don't worry about it. Just thought I'd show that to you.